Hi, I'm David Lapp, product manager on the spatial and graph team at Oracle. I'm pleased to talk to you today about the ability to leverage a converged database platform for location-based contact tracing, and really space and time-based contact tracing, as you'll see as this moves forward. First, to set the context for contact tracing. Contact tracing is front of mind really for all of us with COVID. And we're all very familiar with the traditional notion of contact tracing facilitated by contact tracers, really people that are canvassing and interviewing and monitoring who was with who were those people with, and following that chain of connection through sort of the action of contact tracers. In the middle, we see an emerging area of contact tracing facilitated by apps and devices making use of wireless and Bluetooth and so forth, which are meant to automatically detect proximity based on those technologies. Both proximity and the ability to sort of monitor who was in the same place at the same time. Very important and emerging area for contact tracing. And what it is that I'm going to be focusing on that we see on the right is a spatial temporal analysis approach, which, as we'll see, is as useful for the current crisis and dealing with contact tracing of tracking data where we're tracking people, where people are being tracked, to other types of tracking data, be it ships, vehicles, other types of assets. And that'll become more clear as I go along. So the Converged database platform is really the place where this is optimally performed. So what do we mean by the Converged database platform? Well, in general, what the Converged database platform is all about is being able to handle, natively support all the different data types, so the forms of data in the formats that you need them. So that's row-wise relational data, columnar data, document-oriented data, JSON data, of course, native support for spatial, geospatial data, graph data structures, and data. Workloads such as traditional transactions, but also analytics and artificial intelligence applying machine learning algorithms, developing REST wrappers and handling IoT and sensor data. The real big advantage is around the synergy that exists between those data types and their workloads. So going beyond just being able to handle the different types of data and their workloads, and get into sort of playing nicely between them, moving from native JSON or columnar data into handling geospatial workloads and handing that off to graph analytics, creating REST wrappers for that, all within a converged database. So that means that the spatial temporal analysis that I'll be showing you, the graph analysis, creating service endpoints, that's all stuff that the converged data management platform is able to achieve. What this looks like in our world at Oracle is, from the spatial perspective, spatial features of this converged platform that, of course, support native storing and indexing of traditional point line polygons and collections of geometries, other data, spatial data structures for geocoding, routing, geofencing, etc., and a pretty vast API for spatial analysis and processing. All of the traditional sorts of spatial calculations and filtering and topological relationships, etc. And most recently, a contact tracing API that's part of that native spatial API within the Converged database. And it's that new contact tracing API, spatial API, that I'll be talking more about. So what it does, essentially, is the following. We feed it tracking data. And I'm not showing people here, just showing pins, because again, it could be people, it could be whatever you're tracking. We feed in that tracking data with both space and time thresholds and develop results. And the diagram on the right is basically showing us that based on a set of space and time thresholds, the tracks that we're showing, even though some parts of those tracks across different moving assets or people are very close in time, some are very close in distance, but it's only that extent shown in yellow surrounded by the red box. That's the only area that meets the space-time thresholds and is therefore, in this cartoon example, the extent of contact. And that's really what this API is about, applying space and time thresholds to tracking data to identify contact. Looking at that in a little bit more detail, what we have are, in this case, a diagram showing two tracks with their points and some red arrows showing us the points which meet distance thresholds. Then we also have time thresholds. So what's the difference in time that we'll accept for two locations, two measurements to be considered comparable? And chaining tolerance, which has to do with small gaps between longer durations of contact and whether we would consider some small gap in contact to be truly represent breaking one long piece of contact in two, or does a very small occurrence of no contact, should that be ignored and should the contact be considered to be contiguous? If accuracy is part of the data, it can be included in the configurable tolerances. So an example, we feed into the API some tracking data. Here, in this case, this happens to be tracking data from some bike club tracking through the city of Boston. I'm tracking, have this tracking data. It's simply a unique identifier for who, in this case, or what is being tracked, the timestamp of that tracking. It's being displayed here as a date, but it's actually a timestamp, and the geometry. We invoke the API just through straight SQL, and we supply it the parameters, who it is that we want to identify contact with, and what are those key tolerances. And I'm just showing a few of them, the distance and time tolerances here, and we have a result where we can see who is in contact, where, the geometry tells us where, and for how long. If I change the distance tolerance in this case, of course, I'm going to get a slightly different result. And we can now go and look at a different person altogether. We'll take a look at this in the map. So now I'm looking at contact, who was in contact with user 408 within a given set of thresholds. We see in the map in gray, the gray dots are all of our tracking data. The magenta dots are the user that we are developing contact tracing for. And the results of the contact tracing are what we see in yellow. Those are the points of contact, and in green is the total track of the person that came in contact with our person of interest. If we zoom in, we can see that there were sort of long extents where they were very close in space, but it's only those areas surrounded by yellow that met the space and time criteria or thresholds, and therefore that set of yellow locations constitutes our duration or our episode of contact with a location and time or duration associated with it. If we go in and take a look at a different person to track, here we're going to take a look at a different user 4010 and a distance tolerance of 10 meters, leaving the time tolerances alone, and we can see again in magenta the person that we were doing contact tracing for, and in yellow are the episodes of contact, and in green is the complete extent of the track for who came in contact with the person that we're doing contact tracing for. We can see that there's a couple of long episodes of contact in yellow, and then it's sort of broken there in with the green dots that aren't surrounded, because as the radial widget shows us, we're just outside of that distance threshold. The time threshold actually was fine, but the distance threshold was not. Therefore, those are not considered contact. If I increase our distance threshold from 10 to 15 meters, we can see now that we have this one long duration of contact. So again, based on both the space and time thresholds, we identify with who came in contact with who else. If we zoom back out, we can see that we've identified contact with our person of interest, but there's all those other tracks and all the other people moving around in space and time. And so the natural question is what is the chain of contact between the user in magenta, and then who is in contact with that user, and who is in contact with that user again and again and again. So the next obvious question is, what does the chain of contact look like? We know that the user in green met the contact tracing thresholds, but we now have a whole track for that user with space and time information, so we could find out what other users came in contact with that user. So as we develop contact tracing results across our individuals or moving assets, we then leverage the Converged database to hand off from the spatial temporal analysis to the graph analytics, because they're part of the same Converged database environment. So we develop all the contact results across all of these entities, people, assets. Then we represent that information in our graph data structure, where the objects or the individuals being tracked are vertices or nodes of the graph, and contact or edges in the graph. And we can then apply graph analytics to identify who are the sort of the main actors in, or the main assets or moving objects that are involved in contact or being part of super spreader in a pandemic case, or who are part of clusters, who are part of communities, and so forth. So that's what the Converged database allows us to move into, and that's just one other Converged database feature. We could move on to others. For example, the REST data services feature in the Oracle Converged database environment lets us take all of this and just very easily expose it all through REST endpoints, and we could continue along that path of moving through the Converged capabilities. So hopefully this has been a good introduction to both what the Converged database platform offers, and specifically what this contact tracing API looks like for spatial temporal contact tracing in the Converged database. I encourage you to learn more, take a look at these links, especially the blog that gets into much more detail about the contact tracing API itself. I hope this has been useful, and be glad to answer some questions. Thank you.
So first question was around data source. The example that I showed in the demonstration that you saw was crowdsourced data. The idea of the API and the whole approach that we have here is it's a data model that can accommodate really any source of positioning data, whether it's movement of people or assets, cargo, ships, you name it. And we've actually applied this in a lot of different scenarios. So I was showing data from crowdsourced data, but we are working with other governments. We're working in some other domains around ship traffic, all kinds of scenarios that are all sort of amenable to this approach. So extremely flexible. And I think if you take a look at the blog, you'll get a sense of that. Question, you're calculating amount of movements inside the same area. How about spreading to others? So we're not doing anything with this API per se around movements within, specifically within areas. This is all about looking at tracking data, whatever it is that's being tracked, and according to distance and temporal thresholds, identifying episodes of contact according to those thresholds. Those thresholds can be very, very different depending on the nature of what it is that we're tracking. Sort of the sampling intervals and what it is that it represents. The thresholds make this incredibly flexible, whether we're dealing with data where we're tracking things sort of sub-second or by second or by minute, and what it is that we want to define as being contact. Lots of other sort of variability that we can accommodate with the data model and the thresholds. The address of the blog, I think, was actually in the chat. In the chat that we have here, Mary Layden put a couple of links in there, and one of them is for the blog. And I'm also going to put my email address in here as well. So Anyone that's interested at all, I would encourage you to contact me. I'd be more than happy to get into more detail around this. And the question as well about privacy, elaborate about people privacy management with respect to the tracing API. So again, what we've done and you know what the spatial platform does in general is really provide the spatial, in this case, spatial temporal analysis engine, the data model, the data types, all the infrastructure. And by the way, I should say that this is all part of Oracle Database, which operates traditionally on premises, but this is now all part of the Oracle Cloud. So Oracle's fully managed autonomous database, our sort of semi-managed Oracle database cloud service, where you have a little bit more hands-on control when you need it. This is all part of all of those databases on the cloud and on premises. And we're providing that open data structure and the ability to load and operate these kinds of features. There's nothing in the data model itself that opens the floodgates on privacy concerns. That's really a matter of the sort of the upstream definition of the data that you're loading and the governance around it. So it looks like I'm at or a little past my time, so I'm going to say thank you to everyone. Look forward to hopefully folks being in touch. Thank you.